All right, let's try to integrate nice indefinite integral here where we have natural log of x multiplied by the square root of x to the seventh power. Lot going on here. So what we're going to need to do is use integration by parts. So our formula is sitting over here with u's and v's and the integrating v du. All right, so to get going on this, the first thing we're going to do is pick out what is our u and what is our dv going to be. All right, so in this, I noticed that we have a natural log. That's a big clue that that is going to be our u. Whenever you have a natural log in a problem, make that your u. Basically always works out that way. Now we're going to have everything else. That's going to go as our dv. So I can write this as the square root of x to the seventh dx. All right, now with these, we kind of go two opposite directions. With the u and the natural log of x, we're going to take the derivative of both sides on this. With the dv, we're going to take the antiderivative of this. So first of all, with u, the derivative of that is 1 du. The derivative of the right-hand side is 1 over x dx. Taking the antiderivative over here with the dv, I'm first going to think of this as a fractional or rational exponent. So because it's a square root, that's an index of 2 sitting out in front, this is going to be raised to the 7/2 power. So I haven't actually taken the antiderivative yet. All I've done is rewritten it without a square root, but rather as a rational exponent. Now we can take the antiderivative. So we're going to get v on the left-hand side. And the antiderivative here, we're going to increase the exponent by 1. So 7/2 plus 1, that's like 7/2 plus 2/2 is 9/2. And then we have to either divide by that new exponent, or when you have fractional exponents like this, you can use its reciprocal out in front. So flip it upside down. All right, now that we've collected all this information, let's go over to our formula and see about plugging this in. So in u spot here, we can replace it with natural log of x. In v spot, we can replace it with 2/9 x to the 9/2. Right, that came from right here. And then from that, we're supposed to subtract the integral of, again, I'm going to replace v with this. However, that 2/9, I'm going to go ahead and put that out in front because constants can come out in front of integral symbols. And then x to the 9/2 multiplied by, we're supposed to plug in du at the end. Well, du, you can see over here, is 1 over x dx. All right, so taking a look at that, shouldn't be too bad. We're done with this first part. We could rearrange this, maybe put the 2/9 out in front or the x to the 9/2 out in front, but we're basically done with this. Our next goal is going to be eventually we have to integrate this last part. But before we integrate it, let's go ahead and do some simplifying down. All right, we have 9/2 x's up in the numerator, and we have 1 in the denominator. So if you want to cancel out one of these, that means with this one from the denominator with whatever we have up here in the numerator, we're subtracting 1 away. So you go from 9/2 minus 2/2, that's going to turn back into 7/2. So just kind of copying down everything we have. Like I said, maybe we'll move that 2/9 out in front, x to the 9/2. 2/9 is out in front here. The integral of x to the 7/2, right? 9/2 minus 1 makes 7/2 dx. All right, from here, we just need to integrate this. Did something pretty similar just a minute ago. A lot of copying down stuff. Bring the 2/9 along as constants can come along. But then we're going to take x to the 7/2. We're going to increase the exponent by 1. So again, back up to 9/2. But then we have to either divide by our new exponent or multiply by its reciprocal down here. And at this point, because we've gotten rid of our integral symbol, that's where we put a plus c at the end. All right, we can probably clean this up just a little bit more. Like instead of leaving a fraction multiplied by another fraction, I would probably elect to go ahead and say, well, 2 times 2 makes 4, 9 times 9 makes 81, x to the 9/2 plus c. But as far as leaving rational exponents, that's usually perfectly fine to leave those as rational exponents as opposed to switching them back into radicals. All right, so as you're getting going on these, figuring them out, the important thing is when you're picking your u and you're picking your dv from the beginning, I think that's always kind of the most important part to get moving the right direction on these. If you have a log, a natural log involved, make that the u and make sure that everything else is included with the dv. If you don't have a natural log, you're probably going to look for an algebraic expression to be your u. All right, hope this helps. Good luck as you're practicing these up and getting better at them.